Hello, Algebra 2 students. So today we are going to continue with radical equations, but these particular examples, well, most of them I should say, are going to require us to use our factoring skills that we learned in Algebra 1 to solve. Okay, so the directions are the same from yesterday. Solve each equation and remember to check for extraneous solutions. So the same steps are going to apply to these particular problems. So step number one, you need to isolate the radical. So in problem number one, I have the square root of 8n equals n. So the square root here is isolated on a side by itself. So we are good to go. So the next step is to remember undo that radical. So since it is a square root, we are going to square both sides. So again, that right here, we're going to take both sides to the second power. So we are left with 8n equals n squared. So now we have a quadratic. So anytime you are trying to solve a quadratic, you need to set the equation equal to 0 and then factor. So to do that, I am going to subtract 8n from both sides. So my equation is going to look like 0 equals n squared minus 8n. So if I'm looking at this quadratic, I'm going to stop and think, what can I do? Well, I can factor out an n out of both of these terms. So I have n times n minus 8. And then now that it's factored, we're going to set each factor equal to 0. So one factor here is n, that's going to equal 0. The other factor, I'm going to have n minus 8 equal to 0. And if I solve that for n is going to be 8. So right now, there are two possible solutions. We need to make sure that both of them work. So if I check it, because again, sometimes they don't work. If I check 0, so check for n equals 0. Is the square root of 8 times 0 equal to 0? Well, that's going to be the square root of 0, which is 0, so that one works. So this is a possibility. If I check n equals 8, we're going to have the square root of 8 times 8. Again, does that equal 8? Well, the square root of 64 is 8, so that one does work as well. So I have two possible answers here, n equals 0 and n equals 8. Okay, so if I continue on and look at number 2. So we have n equals the square root of 30 minus n. So the part with the radical is isolated, is on by a side by itself, so I'm ready to continue on. So I am going to square both sides to undo that radical. So we're going to have n squared equal to 30 minus n. So just like I did with the first problem, we are going to, since this is a quadratic, set it equal to 0 so we can solve here. So I am going to have n squared. If I add n to both sides, that'll be a plus n. And again, to move the 30, we're going to subtract 30 from both sides. So again, that equals 0. So now to factor this, thinking back to our Algebra 1 skills, the way this factors, you are looking for two numbers that multiply to give me negative 30 and add to give me a 1. So again, think for a moment. Can you think of two numbers that multiply to give you negative 30 and add to give you a positive 1? So I can think of two. I'm looking at a positive 6 and a negative 5. 6 times negative 5 is negative 30, and 6 plus negative 5 is a positive 1. So now that this is factored, again, this is from Algebra 1, we're going to set each factor equal to 0. So we're going to say n plus 6 equals 0, or my other option is n minus 5 equals 0. In the first case, if I solve for n, if I subtract 6 from both sides, n equals negative 6. In the second case, if I add 5 to both sides, n would equal positive 5. So again, if I check it to make sure they do both work, if I check n equals negative 6 first, does negative 6 equal the square root of 30 minus negative 6? Okay, well, 30 minus negative 6 is a positive 36. And the square root of 36 is 6, not negative 6. So negative 6 does not work. That is what we call an extraneous solution. So again, negative 6 is not a possibility. If we check, what do we have? Positive 5. So does 5 equal the square root of 30 minus 5? Well, 30 minus 5 is 25, and the square root of 25 is 5, so that one works. So I get my solution of n equals 5, because again, n equals negative 6, that was extraneous, that did not work when I plugged it back in. Okay, so if I continue with the next two problems here. So I have the square root of 72 minus n equals n. So again, that part is isolated, so I am going to square both sides. So I'm going to have 72 minus n equals n squared. So since I have a quadratic, I want to set my equation equal to 0 so that I can factor. So we are going to have 0 equals n squared plus n minus 72. So just like in the previous problem, when I factor, I've got to think of two numbers that multiply to give me negative 72, and again add to give me a 1. So hopefully you're thinking of 2. I'm thinking of a positive 9 and a negative 8. So again, to finish solving here, we're going to set each factor equal to 0. So n plus 9 equals 0, or n minus 8 equals 0. So in the first case, if I subtract 9 from both sides, n would equal negative 9. In the second case, if I add 8 to both sides, n would be a positive 8. So again, if I check it to see if it works, let's check the negative 9 first. So the question is 72 minus negative 9 equal to negative 9? Well, that's going to be the square root of 81. And the square root of 81 is a positive 9, not negative 9, so that does not work. If I check positive 8, I'm going to have the square root of 72 minus 8. Does that equal 8? So that's going to be the square root of 64, and the square root of 64 is 8. So n equals 8 does work. Again, the negative 9 does not. That is what we call an extraneous solution. Okay, so hopefully we're starting to get the hang of things here. So if we continue with number 4, again, the part with the radical is isolated, so we are going to square both sides. So I'm going to be left with n squared equals negative 1 minus 2n. So again, what we're going to do is set the equation equal to 0 so we can factor. So n squared plus 2n plus 1 equals 0. So when I'm factoring this, I'm looking for two numbers that multiply to give me 1 and add to give me 2. I'm thinking of some. How about 1 and 1? 1 times 1 is 1, and 1 plus 1 is 2. So this is going to factor into n plus 1 times n plus 1, which really, when I'm solving it, is get the same solution here. So I have n plus 1 equals 0. So n is going to be negative 1. If I check it, check negative 1. Okay, does negative 1 equal the square root of negative 1 minus 2 times negative 1? So again, working this out, this is going to be negative 1 plus 2. Negative 1 plus 2 is a positive 1, and the square root of 1 is 1. So 1 is not equivalent to negative 1. So n equals negative 1 does not work. It's an extraneous solution. So since we don't have any other options, this particular problem, if you remember from Algebra 1, if you get a solution that doesn't work, that's weird to say. If your solution is extraneous and doesn't work, your answer is no solution. So when you're factoring, you're going to get, again, two possible answers. So your final answer is either going to be you have 2 that work, you have 1 that works, or you have none of them that work. That would be a no solution. Okay, so let's take a look at our last two problems here. On number 5, notice the radical is isolated already. So we are going to square both sides to undo that. So we are left with x minus 2 squared equal to 2x plus 20. So this one's going to take a few more steps here, because when I'm squaring x minus 2, that is really saying x minus 2 times x minus 2. So again, if we are thinking back to our Algebra 1 rules, we are going to distribute to multiply this out. So x times x is x squared. X times negative 2 is negative 2x. Negative 2 times x is another negative 2x. And negative 2 times negative 2 is a positive 4. And again, that is still equal to 2x plus 20. So if I simplify the left side a little bit more here, we're going to have x squared minus 4x plus 4, again, equals 2x plus 20. So since it's a quadratic, we need to set our equation equal to 0 so we can solve. So if I subtract 2x from both sides, and let's go ahead and also subtract the 20, we are left with x squared minus 6x minus 16 equals 0. So now we're ready to factor. So can you think of two numbers that multiply to give me negative 16 and add to give me a negative 6? Hopefully you're thinking a negative 8 and a positive 2. Negative 8 times 2 is negative 16. Negative 8 plus 2 is a negative 6, so we're good to go there. So to solve, we're going to set each factor equal to 0. In the first case, if I add 8 to both sides, x is going to be 8. In the second case, if I subtract 2 from both sides, I will get a negative 2. So again, we need to check to see if both work, or if only one works, or neither work, then we get a no solution. So again, we need to see what happens here. So let's check x equals 8 first. So does 8 minus 2 equal the square root of 2 times 8 plus 20? So 8 minus 2 is 6. On the right, we have 16 plus 20. 16 plus 20 is 36, and the square root of 36 is 6. So x equals 8 does work. If we check the other one, x equals negative 2. If we plug it in, negative 2 minus 2, does that equal the square root of 2 times negative 2 plus 20? So on the left side, we have a negative 4. On the right side, we have negative 4 plus 20 underneath your square root symbol. So we're going to have negative 4 equals the square root of 16, and the square root of 16 is a positive 4, so that one does not work. So x equals negative 2 is an extraneous solution. So my answer to the question for solving is x equals 8. Okay, so hopefully we're starting to get the hang of this. Let's do one more just to make sure. So we have 1 plus the square root of 7 minus 7r equals r. So this one is the first one out of all these examples where your square root, your radical, is not isolated. So the first thing I need to do would be to subtract 1 from both sides. So we're going to have the square root of 7 minus 7r equals r minus 1. So if you notice now, it's very similar to the problem we just finished. So our next step is going to be to undo the radical. So we are going to square both sides. So we have 7 minus 7r equals, and then when you square r minus 1, that's the same thing as saying r minus 1 times r minus 1. If I distribute, just like I did on the previous problem, r times r is r squared, r times negative 1 is negative r, negative 1 times r is also a negative r, and negative 1 times negative 1 is a positive 1. My next step is going to be to simplify the right side of the equation. So again, 7 minus 7r equals r squared minus 2r plus 1. So since it's a quadratic, I need to get the equation equal to 0 so I can factor. So I'm going to subtract 7 from both sides, and I'm also going to add a 7r to both sides. So I'm going to left with 0 equals r squared plus 5r minus 6. So now that's equal to 0, and I've combined like terms. I'm going to factor. So can you think of two numbers that multiply to give me negative 6 and add to give me a 5? Okay, I'm thinking of r plus 6, r minus 1, because 6 times negative 1 is negative 6, and 6 plus negative 1 is positive 5. So again, when I'm solving it, I'm going to set each factor equal to 0. So in the first case, I'm going to get r equals negative 6. In the second case, I'm going to get r equals positive 1. And again, if we check it, we're going to check both possibilities to see which one works. If we check r equals -6 first, we're going to have 1 plus the square root of 7 minus 7 times -6. Does that equal -6? So we have 1 plus the square root of 7 plus 42. 7 plus 42 is 49. The square root of 49 is 7. And 1 plus 7 is 8. That's not the same thing as -6. So -6 does not work. That's an extraneous solution. If we check the other one, r equals 1, we're going to have 1 plus the square root of 7 minus 7 times 1. Again, does that equal 1? So this is going to be 1 plus the square root of 7 minus 7. Okay, well, 7 minus 7 is 0. And the square root of 0 is just 0, so we have 1 equal to 1, and that does work. So r plus 1 here, or I'm sorry, r equals 1 is my solution. Okay, so again, that covers a few more examples on solving radical equations, but again, these that we're looking at in this particular lesson require you to factor. If you have any questions, please let me know.